Welcome back to another video. In this video, we're going to be talking about compound interest. Now, if you watched the last video was about simple interest, and that is interest that is calculated only on the principal, okay? So now compound interest is interest being calculated on the principal plus any accumulated interest that's been added to the account. All right, so once interest has been added to the account, then when new interest is calculated, it includes that interest that has been added to the account previously. All right. Now the formula for compound interest looks like this. A equal P times 1 plus R over N raised to the N times T. Now all of the variables here are the same except there's one new variable. All right. So last time we had that A was the future value, and that's still the case here. A is your future value. P is the original amount of the deposit or the original investment amount. So we say that's the deposit amount or the original amount. R is still the interest rate. And remember, the interest rate is always as a decimal. T is still the time in years. Okay. So all those are the same, and the only new variable that we have here is N. N is the number of compound periods per year, alrighty? So N is the number of compound periods per year. So there are a few different scenarios that can happen as far as compound periods. So you can have where the interest is compounded annually. So compound means how many times the interest is added or when the interest is added to the account. So every institution has a different compound period. So if your institution, financial institution, says that they compound interest annually, that means that N is equal to 1. That means they compound interest once a year, and the length of that investment or the length of that time is 1 year. All right, that means your money sits in an account for 1 year, then they calculate the interest and they add the interest to the account. Another one is semi-annually. So semi-annually means twice a year. That means N is 2, and that means they compound interest every 6 months. So every 6 months, your bank will add interest to your account or whatever financial institution you're using. The next one is quarterly. Quarterly, N is equal to 4. And that means that if you take 12 months and divide it by 4, that means that interest is compounded every 3 months. Another one is, what am I missing? Oh, monthly. So if interest is compounded monthly, then N is equal to 12, and the length of that time frame is 1 month. So every month your financial institution will add interest to your account. And then the last one is daily. So now I know that there are 365 days in a year, but when it comes to these financial formulas, most of the time they use N is equal to 360. And so N equal 360, the length of that compound period is supposed to be 1 day. So we're assuming that 1 year has 360 days in it. So that means every day your financial institution will add interest to your account, okay? So that's what the N is in this formula, and it will change depending on how the interest is compounded. All right, so let's look at an example. Example 1, you deposit $7,500 in a savings account that has a rate of 6%. The interest is compounded monthly. So compound interest is the key word to let you know what formula to use. We want to find two things. How much money will you have after 5 years? And the second thing is find the interest after the 5 years, okay? So the first thing we need to do is identify our variables, okay? So we're trying to figure out how much will we have after 5 years. That means we're looking for the future amount. So we're looking for A. So we need to figure out what is P. P is the amount of the original investment, which was $7,500. What is R? R is the interest rate. Now the interest rate is 6%, but remember you have to convert 6% to a decimal. So if you move the decimal to the left 2 times, that becomes 0.06. T is the length of time of the investment in years, and it says we want to figure out how much we'll have after 5 years. And then the new variable N is the number of compound periods per year, and since it's compounded monthly, that means N will be equal to 12 because there will be 12 compound periods in a year. So once you identify all of your variables, then you just plug them into the formula. So A is equal to 7,500 times 1 plus R over N. So 0.06 over 12. All of that raised to the 12 times 5. N times T. Okay. So now the rest is just really plugging it into the calculator. So let me grab my calculator. When you plug it into the calculator, I would definitely recommend doing the inside of the parentheses first. So I would actually do the 0.06 divided by 12 first, and then add the 1 to that. And so if I rewrite this, this is 7,500 times, I get 1.005 inside the parentheses, and 12 times 5 is 60. So then if you rewrite it like that, you can actually plug that into the calculator just like that. So 7,500 times 1.005 raised to the 60th power. Now, I don't know if y'all can see. Let me see. So I'm using the little caret key, which is that key right there, to raise to a power. Some of you all may have a button on your calculator that looks like this, X to the Y. That also allows you to raise to the power, but I'm using the caret key that looks like that to raise to a power, okay? So that's 7,500 times 1.005 raised to the 60th power, and I get A is equal to 10,116. And again, since this is money, you want to round it to the nearest cent. So that means the future value will be $10,116.38, okay? So you originally deposited 7,500. You let it sit for 5 years. At the end of the 5 years, this is how much you'll have if it compounds at 6% interest compounded monthly. All right. Now, it also wants us to figure out how much interest did we earn. So if we end up with $10,116.38, then the interest will be found by basically taking that amount and subtracting what you deposited, the 7,500, from it. So if you subtract 7,500 from that, you end up with $2,616.38. So that means you were able to gain $2,616.38 just by letting your money sit in that account. Now, to be completely honest with you, that is a really, really high interest rate, 6%. You don't really find interest rates like that anymore. Maybe once upon a time, but now interest rates are usually less than 1%. If you can even get to 1%, then that's a good percentage. But this is a good interest rate. So the moral of the story is to try to find the best interest rate on your investments when you can. The higher the interest rate on the investment, the better. The lower the interest rate on the loan, the better. Okay. All right. Let's look at something else. Okay. We also have what's called continuous compounding. Now, continuous compounding means the number of compounding periods increases infinitely. All righty. So what that means is that your money is calculating interest every minute, every second as we're speaking. It's continually calculating interest, and it's being added to your account. All right. Now, it sounds like an amazing thing, right? But when you really work it out, it's not too big of a difference from the compounding periods. But it's still better than just compounding it monthly or annually or semi-annually, okay? And so the formula for continuous compounding is A equal P E to the RT. Now, A is still future value. P is still the principal or present value. R is still the interest rate. T is still the time of years. The only thing that's new here is this E. This E is what we call Euler's number. And E is an irrational number like pi. So you know how like pi is 3.14 and really some more numbers? Well, E is that same type of number, except it's 2.71828 and some more numbers, all right? So E is an established number, and there's an E button on your calculator. So depending on what kind of calculator you have, my E to the X button, I have a graphing calculator, TI-83. It's on the LN button, and it's that, I don't know, it's blurry. But it's like you have to push second and that button there. If you have a phone, let me see. E is also on your phone. Let me see, on your phone calculator. Well, depending on what kind of phone you have. But usually, so I have an iPhone. This is what the calculator look like if you hold it up right. But if you turn it to the side, you get some additional things. And so on here, you have E, and my E is, so you have E to the X. E to the X is here. I don't know if y'all can see that. And E is here. E to the X is when you want to raise it to a power, which is what we want to do here. We want to raise E to a power. So, we will use that E to the X button. All right. Don't mind my nails, y'all. They need to be repainted while I'm over here pointing and showing y'all stuff with them. Okay. So let's look at an example. So the key word is continuous compounding. So let's see how this continuous compounding plays out. So example 2, you decide to invest $8,000 for 6 years, and you have a choice between 2 different accounts. The first pays 7% per year compounded monthly, and the second pays 6.85% per year compounded continuously. Which is the better investment? All right, so first of all, let's just identify the variable. So first of all, we're depositing $8,000. That means our P is 8,000, and we're depositing it for 6 years. So T is 6. All right. So those 2 things will be consistent across both accounts. Now, the thing that changes is with the accounts, the interest rate and the compound period changes. So for option 1, we have an interest rate of 7%. So R is equal to 0.07 if you convert that to a decimal, and it's compounded monthly. So N is equal to 12. So for option 2, we have that R is equal to 6.85%. So if you calculate that to, or convert that to a decimal, R would be 0.0685. And it's compounded continuously. So there is no N in this case. That means we're using a whole different formula, all right? So we want to use both of these formulas to determine which one will give us the better, which one will give us more in the end. So for this first one, we'll use the continuous compound formula because it's not the continuous compound. We'll use the compound interest formula because it gives us a number of compound periods. So that would be 8,000. So remember, it's P times 1 plus R over N raised to the N times T. So that will be the formula for the first one. And then for the second one, we will use the continuous compound formula because it says that the interest is compounded continuously. So that would be P times E to the R 0.0685 times T, so times 6. All right. And so the rest is just plugging it in the calculator and figuring out which one gives you the better yield or the better return. So again, if I'm doing this, I would start with the parentheses. So the 0.07 divided by 12, add 1 to it. So you get a repeating decimal, 1.00583 repeating. 12 times 6 is 72. So I would take that 1.00583 and raise it to the 72nd power and then multiply by 8,000. So plugging in the calculator, you have to be really, really careful because it's easy to plug it in wrong and make a mistake. All right. So here I get $12,160.84. Okay. So that means after I let this $8,000 sit for 6 years, at the end of that 6 years, I have $12,160.84. All right, now I want to plug this one in. And this with the E, you can plug it in just like it is. So you would do 8,000 times, you do the E to the X button, and you do the 0.0685 times 6. And for that one, I get $12,066.60. All right, and so if you look at both of those, you can see that this one gives you a higher return. It comes out almost $100 more than what this one will give you. And so option 1 would be the better option. Now remember, I did mention that continuous compounding was the better option, but in this case you have to look at the interest rates. This one had a higher interest rate than that one, and so that's why this one came out to give you the better return, because of that interest rate being higher. All right. If you have any questions about anything from this problem, don't hesitate to ask them in the comments or send in a personal email. Now, in some cases, we want to solve for the principal, meaning we want to figure out how much do we need to deposit now in order to have a certain future amount in the future. All right. And so in that case, we would take our compound interest formula and solve for P. So now, since this says P times 1 plus R over N to the NT, to get rid of all of this stuff, we would just divide it out. So divide out that 1 plus R over N to the NT by both sides. And then you'll get a formula for P that you can use every time. And so I'm just going to write the P on this side. P ends up being A over 1 plus R over N raised to the N times T. All right. So that's the formula that will solve for the present value, meaning how much can you deposit now to have a certain future value if you know all of these other conditions, the interest rate, the number of compound periods, and the time that you're going to want that money to sit in there. All right. So let's look at an example on using this. So for example 3, you want to figure out how much money should be deposited today in an account that earns 6% compounded monthly so that it will accumulate to $20,000 in 5 years. So now the key is, how much money will you have to deposit today? That means you're looking for the present value. So that's letting me know that we are trying to solve for P. All right. So this is example 3. Now what we do know is that we wanted to sit in an account that earns 6% interest. So your R would be 0.06. We wanted to sit in there for 5 years. So your T would be 5. And we wanted to accumulate to $20,000. So our A, which is the future amount, would be $20,000. We also know that it's compounded monthly. So our N will be equal to 12. And so now we just plug all of that in the formula for P. So P is equal to A, which is 20,000, all over 1 plus R, 0.06 over N, which is 12, raised to the N times T. Now again, when you go plug this in the calculator, I would again start with the parentheses, which is the 0.06 over 12, and then add the 1. And so that ends up being 20,000 over 1.005 raised to the 60th power. And then if you divide that just like that, you end up getting $14,827.44. So that lets me know if I want to invest a certain amount of money in this account, I will have to invest $14,827.44. Let that sit in this account for 5 years, and at the end of 5 years, I'll have $20,000. So that's how you will use that formula for P whenever you want to figure out how much you have to invest now to get a certain amount in the future. Now, the last thing we want to talk about is what's called the effective annual yield. Now, the effective annual yield is determining the simple interest rate that will give you the same amount after 1 year that you would get in an account that was compounding interest. Okay, so remember, the simple interest only compounds interest on the principal amount, but compound interest compounds interest on, or it adds interest on the principal plus any interest that's been added to the account. So the effective annual yield actually gives you how would you get that same amount from compound interest using simple interest, and what interest rate will give you that same amount. Okay, now there's a formula for the effective annual yield, and the formula is Y equal to 1 plus R over N raised to the N all minus 1. And that's how you find the simple interest rate to give you the same result of a compound interest. All right, so let's look at an example. So example 4, I'm going to leave this formula up here. Example 4 says a passbook savings account has a nominal rate of 5%. The interest is compounded daily. Find the account's effective annual yield. Okay. So it gives us the nominal rate, which is the interest rate for the account, is 5%. So our R is 0.05. It also tells us that the interest is compounded daily. So that means our N is equal to 360. So remember, N is, there are 365 days in a year, but for these calculations, we assume that there are 360 days in a year. And so then you just plug those into this formula to figure out what the annual effective yield is. So R is 0.05, N is 360. All of that raised to the 360. All of that minus 1. So again, when I'm calculating this, I will start with the inside of the parentheses. So the 0.05 divided by 360. I will add the 1 to it. Then I will raise it to the 360 power. And then I will subtract 1 from it. And when I do that, I get 0.0512674465. So some long numbers, right? Now this is a decimal, and remember this is a rate. So what we have to do is go back and convert this rate to a percentage. So I will move the decimal to the right 2 times. And so that would give me 5.1. If I round it to the nearest hundredth, that would be 5.13%. Okay. So in the compound interest, I will use the 5%, but the simple interest rate that will give me the same result as the compound interest one will be 5.13%. So the simple interest will have to be higher in order to get the same results from the compound interest. All right. Hopefully this all makes sense, and hopefully you find this very beneficial, because this is definitely applicable to our lives, to things that we go through when it comes to investing, putting our money in savings accounts and things of that nature, taking out loans. We need to know how to be able to calculate these things. All right. So if you have any questions whatsoever, again, don't hesitate to put them in the comments. Do not hesitate to send me a personal message. I will respond. I look forward to seeing emails and questions. And so thanks again for watching. And if this video helped you at all, make sure you hit that thumbs up, that like button, help me get in that YouTube algorithm. And if you haven't already, go on and hit the subscribe button too. And I thank you, and I will see you in the next video.